Hello and welcome to part 2 of your review for exam 1. I'm just going to go over a few things that the first part left out, starting with this problem. Find where f of x equals g of x and where f of x is greater than g of x. F of x and g of x are defined respectively here, and conveniently they're input in Desmos over here. Now, a lot of times when you open up Desmos, it has a window of -10 to 10 on the x-axis and -10 to 10 on the y-axis or something like that. You can change that window with the settings over here. You can change things. I think we're okay on the x-axis. On the y-axis, maybe I want to go a little further down, maybe -50, and then up to something. I'll just leave it like that for a second. Now you can kind of fine tune things a little bit if you want to by just moving things around, but that moved things too far down. The nice thing you can do is hit the shift key with your cursor on one axis or the other. If you hit the shift key and then scroll, that can also zoom in or zoom out. So this is what I wanted. I wanted a picture that showed all the points of intersection between these two functions. To find where these functions are equal to each other in Desmos is particularly easy. All you have to do is click. So there we go, -6.171, -1.312, and finally 1.483. So let's write those down. Let's see. X equals -6.7171. -1.312, and finally 1.483. Notice I'm writing down just the x coordinates. That's all you're asked for right now, at least in the first part, is to find where these two functions are equal to each other. So that's part A. Part B asks you, well, where is f of x greater than g of x? Looking back at our graph, it's in this interval. We already know where these points are. So from -6.171 to -1.312, that's along the x-axis. So it's just those x values. That's all I want for the answers. If you give me the coordinates, both the x and y coordinates for both these points, you'll make me unhappy as I grade your paper, and that's never a good thing. So -6.171, comma, -1.312. And then there's another place where the red graph is taller than the blue graph, and that's to the right of 1.483. So 1.483. And it stays above that graph, well, kind of forever. So if I zoom out a little bit, or along the y-axis, you can see that this function keeps going up, whereas our parabola bends down. So to the right of that point, it's always greater than, let's see, there it is. It's always greater than g of x. Now, as far as your answer is concerned, a couple things to take note of. First of all, because this is a greater than or equal to, we can actually include the endpoints. Quick question for yourself, parentheses or brackets? I'm hoping you said brackets. Over here, again, a bracket, and f of x is greater than g of x from here out to forever. And for us, that's infinity, which always gets a parenthesis. Yay. The second problem is something like I did in the first video. I've got a better way to simplify these. I think you'll like it. Let me remind you of this. When I multiply things with the same base, what happens with their exponents? Oh, you add them. Yes. So that's the idea we're going to use here, along with the idea that we can always multiply something by 1 to simplify it. So let's see. 3 plus x squared to the 1/2 minus x squared times 3 plus x squared to the -1/2 over 3 plus x squared. Now in the denominator, if you wanted to, you could think of this as being to the first power. The big problem in this is this negative exponent. It really becomes a denominator, making this a complex fraction. It's kind of a pain. So here's what I'm going to do. As advertised, I'm going to multiply by 1. I'd like to get rid of this. And to get rid of this, the exponent has to be 0. What do I have to add to negative 1/2 to make this 0? So I'm going to multiply by something. So I'm going to multiply by 3 plus x squared over 3 plus x squared. But I need the right power. What would you add to this to get a 0? We'd add 1/2. So I'm going to multiply by 3 plus x squared to the 1/2 in both the numerator and denominator. So let's do this. I'm going to put brackets around this. And the reason I'm putting brackets around this is because this has to distribute itself to both terms. Now here, there's no distributing. I'm just multiplying two things with the same base. So let's start in the denominator. When you multiply things with the same base, I add the exponents. 1/2 plus 1 is 1.5, or 1 times 2 is 2, plus 1 is 3/2. And that's the way I'm going to write this, as 3 plus x squared to the 3/2 in the denominator. So let's do that over here. So I'll have 3 plus x squared to the 3/2. Oops. And I don't need that extra parenthesis there. So apply a little Photoshop. What's going to happen here? When you multiply things with the same base, you add their exponents. So I'll get 3 plus x squared, this time raised to the first power, minus x squared times 3 plus x squared. And again, remember, you're multiplying this, you're distributing it to this whole term here. And when you do that, you add the exponents. And that gives you a big goose egg, which is really cool. So this further simplifies as 3 plus x squared minus x squared times 1. I wrote that in the wrong order. So minus x squared times 1. All over 3 plus x squared raised to the 3/2. Well, times by 1, that 1 is coming from this part right here. 3 plus x squared to the 0 power, that's where I got that 1. I don't really need to write the times 1 here, so let me get rid of that. A little more Photoshop. And now I've got 3 plus x squared minus x squared. And yes, the x squareds can cancel at this point, and you're left with 3 over 3 plus x squared raised to the 3/2. And that's it. Nice. We spent a lot of time with net change and average rate of change. So let me refresh you a little bit on those. If I want to find the net change in the function between 1 and 3, the first thing I got to do is find the values of the function at 1 and 3. So at 1, f of 1 is 2. At 3, f of 1 is going to be 7 minus 5 times 9, or 3 squared. 7 minus 45 is negative 38. The net change is just the difference in the y coordinates. So the net change is going to be negative 38 minus 2, for a net change of negative 40. It's just the change in the y coordinates. Now, if I want to go a little bit further, I can do the average rate of change. Let's just pick up the same points from up above, 1 and 3 to -38. The only difference between net change and average rate of change is you're going to take the net change and divide it by the change in the x's. So it's really just the slope of a line. So the average rate of change you can think of it as the net change divided by the change in x. I'm going to write it all out. It's just the slope of the line between these 2 points. So -38 minus 2 over 3 minus 1. -40 over 2 is -20 for my net change. Average rate of change, sorry. Net change was -40. More likely than not, you're probably going to get a problem with the average rate of change between a number and a close by number, 2 plus a little bit of a number. We're going to call it h. Now we're going to do the same thing as before. We're going to make ourselves a little table and then find the slope of a line between those 2 points. So this is your net change. Sometimes I call that delta y. Delta is a Greek letter, it means change in. Let's make ourselves a little t-table. X, f of x, 2. What do I get when I plug in 2 to the function? That's going to be 7 minus 5 times 4. 7 minus 20 is -13. Then I need to find the function and evaluate it at 2 plus h. And here's where we're going to have to do a little bit of work. Might extend onto a different sheet. So f of 2 plus h is going to be 7 minus 5 times 2 plus h squared. Now do me a favor, when you square this, don't give me 4 plus h squared. You can't distribute the 2 like that. Instead, what you're going to get is 7 minus 5, 2 plus h times 2 plus h. Let me demonstrate that on a little separate sheet here. You're going to FOIL that out. 4 plus 2h plus 2h again, and that's always going to happen when you're squaring a binomial, is you get the middle term twice. So what you'll end up with is 4 plus 4h plus h squared. Finally, let me distribute the 5 and collect up like terms. That's going to be 7, which stays there. -5 times 4 is -20, minus 20h minus 5h squared. 20h minus 5h squared. Quick question for you. How come I can't combine these things first and just go, oh, that's 2 times this? That would be wrong because the order of operations says you have to do multiplication before you do addition or subtraction. So I can't subtract these until I distribute that -5. I end up with 7 minus 40h minus 5h squared. And let's get that back on track here. So let's see. No, that's not right. 7 minus, no, that wasn't right at all. Back, let's get rid of the 7 because I can combine some like terms. My mistake was I thought this was a 20h. Just wasn't paying careful enough attention. 7 minus 20 is -13 minus 20h minus 5h squared. That looks a little bit better. Actually, a lot better. So -13 minus 20h minus 5h squared. As before, we want to find the slope of a line between those 2 points. So let me just call it m sub av. It's going to be the difference in the y coordinates. So this one minus this one, negative 13 minus 20h minus 5h squared minus negative 13 over 2 plus h minus 2. Pause the video and see if you can't simplify this a little bit. It's going to simplify a lot. Negative 13 plus 13, those cancel. How about the denominator? Well, 2 and 2 cancels. So negative 20h minus 5h squared over h. Don't cancel this h into this h, or this one into this one. My suggestion would be to factor out the h from the numerator, h times negative 20 minus 5h. Notice you took out 1h here and 1h here. After you take those out, then you could cancel them and you're left with negative 20 minus 5h. If you want to factor out the negative 5, that's fine. The biggest thing that I'm looking for is for you to cancel out that h. There's your answer. Nice. Okay. One last one here. Solve the inequality, answer in intervals. The first thing you have to do is you have to write this with one arithmetic expression as one fraction. So to do that, I'm going to need a lowest common denominator. When you're adding something, it's almost as if you have parentheses around these things, because you can't say that the common denominator is x plus 4. That's not true. You have to regard these as their own terms. So the LCD is going to be x plus 4 times x minus 2. And in looking at this, well, I know that I don't have the LCD. So let's get each of these fractions set up with the LCD. I'm going to have to multiply by 1. Here, I'm missing the x minus 2. So I'll multiply by x minus 2 over x minus 2. So you're multiplying by 1. Over here, I'm going to multiply by x plus 4 over x plus 4. So let's distribute the 3. That's going to give you 3x minus 6 over x minus 2 times x plus 4 minus, and I'll distribute the 5. Notice I'm keeping the minus here. You can distribute the negative 5 and just make that a plus. I'm keeping it for the moment. It's going to be 5x plus 20 over x minus 2 times x plus 4 less than or equal to 0. The tricky part, and I chose this one particularly because it's got a negative, is that in order to combine these things, I got to subtract the numerators. So it's going to be 3x minus 6 minus 5x plus 20. But if you're watching my work carefully, I've kind of made a mistake here. That negative has to distribute itself to both terms. So it's either right with parentheses or just distribute it right away. Something, be careful. So this becomes 3x minus 6 minus 5x minus 20 over, now I'm just going to get lazy. I'm just going to write the LCD just for the moment. Finally, I've got like terms that I can combine. So 3x minus 5 gives me negative 2x minus 26 over, and let's write it again. x plus 4, x minus 2. I want to know where that's less than or equal to 0. Whew, long ways to get here. Let's see what happens from here. We're going to need to know where the numerator equals 0. That's going to be negative 2x minus 26 equals 0. Or negative 2x equals 26, or x equals negative 13. As far as where the denominator equals 0, that we can kind of read off. That's going to equal 0 when x equals negative 4 or x equals 2. I'm going to put all those points on a number line and then do a little bit of testing work. Now you can test these in Desmos or your graphing calculator. Here I'm going to show it with your graphing calculator because that's most likely what you're going to be using moving forward from this class. We're going to test them in this inequality. I want to test this expression. I want to know where that's less than or equal to 0. So let's put those numbers out on the number line. The only thing that really matters is that you put them in order. Doesn't matter how well you space them. You got negative 13 to negative 4 to 2. That creates intervals at negative infinity to negative 13, negative 13 to negative 4, negative 4 to 2, and 2 to infinity. Your answer to this problem is going to include one or more of these intervals. We just got to decide where it's positive, where it's negative. By it, I'm talking about this expression. In particular, we're looking to see where this is less than or equal to 0. So a reminder as to your settings here. Let's clear that out. I'm first going to start by clearing this out and inputting the function. Now I'm going to input it in a kind of a standard way that everyone can do, with a left parenthesis around the numerator, negative 2x minus 26, parenthesis, divided by, parenthesis again, and then another parenthesis, x plus 4, left parenthesis, x minus 2. And then two parentheses. That closes off the denominator. Now, unless you're doing some statistics work, it's likely that you don't want this plot turned on. If you get an error saying something about dimensions, it's because this plot is turned on. So go up here, press the Enter key, and make sure it's shut off. None of your plots should ever be on for this class. Okay, let's check our table settings. Second table, independent should be set to ask, dependent should be set to auto. If that's good to go, great. If not, make some changes. Hit the second key, then the graph key once you've got those changes made, and that's going to take you to the table function. Here's where we get our calculator to test our points for us. So we learn where it's positive or negative. So let's come up with some good test points. So I need something in this interval here, and this interval here, here, and here. 0 is always a good test point, so I like choosing that one. I need something to the right of 2. We'll choose 3. I mean, you can choose 3 million, you can choose pi, whatever you want, but I like the keep it simple principle. Something to the left of negative 4 and something to the left of negative 13. Make sure that you have 1 point per interval. It'll throw off your calculations wildly if you don't. Start with negative 14, negative 5, 0, and 3. Now, the information we want here is not that I got, for instance, 1/80th over here, but rather that it's positive. And in the next interval, the function's negative. After that, the expression's positive, and then negative again. So negative, positive, negative, positive. Let's write that down. It was negative, positive, negative, positive. I wanted the negative intervals because I wanted to know where this expression was less than or equal to 0. So that implies the negative intervals. So here and here. Don't just go automatically assuming that I'm always going to give you the positive intervals or a greater than inequality. You're going to have to look at what I'm giving you. The last part of this, if you remember back here, this was the less than or equal to sign. So I could use maybe one or two of the endpoints, but I've got it checked. It's okay if it's equal to 0. It's not okay if it's something else. So let's test at negative 13. Can I use negative 13? Well, if I put in negative 13, then I end up with 0 less than or equal to 0. Plugging in negative 13, the numerator is 0, divided by whatever in the denominator, it's still 0. 0 is less than or equal to 0. That's true. So I'll include the endpoint there. So the first part of my answer is going to look like this. Negative infinity to negative 13. And if I'm including that, does that get a brackets or parentheses? Bracket, well done. Can I include negative 2 or 4, excuse me, negative 4 or 2? Well, if I type in negative 4, oh, I can't use negative 4 because that gives me an error. I'm getting an error because negative 4 would put a 0 in the denominator, and you can't divide by 0. What do you think is going to happen if I put in a positive 2? Yeah, same thing. So just to test it out, I'll put in a positive 2. And again, I get an error. So I can't use either endpoint for that interval. That's okay. My answer is this. Make sure that you try and use 2 separate intervals. Don't give WebAssign inequalities for this kind of an answer. It won't like it. It's looking for intervals. All right, I hope that helps. Good luck, and we'll see you next week.